All right, L'Hopital's rule, okay, is our final method to solve limits. Okay, and the reason it's in derivatives is because we use derivatives. Okay, so it's a method to solve limits using the derivative. Right. You'll probably, honestly, you'll probably try to use it quite a bit.
Well, I succeeded in using it quite a bit.
I hope so. Okay, so the best way I think to approach this is just to give you an example. So if I have a limit as x approaches 2, x cubed minus 8, x to the 4th plus 2x minus 20. I give you a limit. What do you do first?
Try. Plug in.
You plug and chug, right? Same rule applies. Plug and chug.
Doesn't work.
What do you get?
0.
Oh, what's that called? Indeterminate form, right? Okay, that is a condition of using L'Hopital's rule. You must have an indeterminate form, just like to use algebra. So that's nothing new, right? Okay, now we can use L'Hopital's rule, and here it is. You can derive the top and the bottom of that limit, and if it gives you a number, you get the right answer. Okay, so we're going to derive the numerator and denominator separately. Okay, they're two different derivatives. Are you tempted to use the quotient rule here?
Yes.
Please do not. Okay. What is the derivative of just the top?
3x squared.
Okay. Okay, so we're doing them separately. What's the derivative of the bottom?
4x cubed plus 2.
There's your new limit. Now what do? Plug and chug.
Does that say numerator and denominator? Yeah.
Am I going too fast?
Yeah, is it?
Okay. I just get so excited. Calculus. I was watching Speed Racer with my family yesterday, the live action human movie, Speed Racer. And there was a calculus joke in it, and I thought it was hilarious and nobody else understood. Come on, it's a Bernoulli converginator. I just didn't get it.
Quick thing, your kids are also super young. I don't think they understand.
I expect a lot out of my children. All right, so
Expect them to ruin children's lives by
plug and chug. What do you get?
12 over I can't 38. No, 34.
Thank you.
3 over 8. No.
Divide by 2, you get 6 over 17. There's your answer. It's even easier than algebra. Yeah?
Yes.
Yeah, so it's a useful tool in a lot of situations where you can derive top, derive bottom, plug and chug, you get your answer. Okay. Why? Do you really want to know?
Never mind. I was so going to say why.
I'm pretty sure that we don't want to tackle that.
Yeah.
I'm going to use this on the AP.
Why? You know, a lot of when you ask why,
I didn't mean
a lot of
why.
times,
Nobody
if
will
it's
add it on.
at your level, it's in the book. Guess what?
It's not in our
This
book.
is not in the book.
Oh, it's not in the book?
No, that answer is not even in our book. So let's solve another limit.
Is that in the There's actually a really
Logic math book that you showed us?
No.
No, not even there.
So is this technically below our level?
I think.
Oh, we had
Yeah, I'm going to show you 3 or 4 or 5 examples that you can apply this to different functions. Okay. So, what's, if I plug and chug, I get sine at 2 pi is, okay, so we got an indeterminate form. We can now L'Hopital's rule.
So how do you identify that it's L'Hopital's rule? That's what you're doing.
You don't have to.
So you can just.
You have to analyze,
Okay.
and then you don't have to write. I like to write this just because it keeps me organized.
You understood it.
Yeah. A lot of times, like, it'll be a multiple choice question. This is the first year it's actually on the AB exam. This has never been on that Calc AB exam before until this year. So you'll probably see a multiple choice question or two. You might even see a free response.
Wait, what do you mean your first time it's ever been on?
What?
I imagine you would respond to L'Hopital's.
So multiple choice, obviously, you can just do your work, answer, right? But a free response, you'll want to be a little bit more organized. Okay. So if I use L'Hopital's rule here, what's the top going to be?
Negative.
Negative, thank you. And the bottom?
Cosine would pi stay.
Pi x. So that's the chain rule, right? Derivative outside, copy inside, and then derive the inside. So what do I have to multiply this by?
Pi.
Pi. Okay. And then plug and chug. -4 over. Cosine at 2 pi is 1. And just leave it like that.
-4 over pi.
Cosine pi x times pi.
How do you reduce the pi?
What?
It was -2x over cosine pi x times pi.
Right.
How do you get to the pi?
Plug 2 in. What's cosine at 2 pi? 1. 1 pi. Not near enough pi's for us, but we'll deal with it. Okay, so another illustration of L'Hopital's rule. There you go, right? Reflexes. Let's try another one. Huh?
That irks me. What?
Cosine squared x over 1 minus sine x.
No, that's not sin x. There's sin squared x.
No. Wouldn't matter.
Would-
Cosine x, cosine of pi over 2. Anybody?
Wait.
Cosine pi over 2 is 1.
Is not 1.
Zero.
0.
Well, if we're supposed to
Cosine
use
comes
them,
from-
you just gotta kind of assume that something's 0 and
The bottom will equal 0.
You gotta check though, because sometimes, okay, this is 1 minus 1, which is, okay, so we can L'Hopital's rule this, right? Derivative of the top.
That's a chain.
negative 2 side.
Chain rule problem.
So it's dou.
What's the outside function?
Squared.
Squared.
Ah.
Yeah.
Remember, you can rewrite that.
It's cosine x squared.
like that. So we need to power rule the outside, right? So 2, copy the inside.
Wait, is it power rule?
This is a chain rule problem. The derivative of the outside is a power rule. Bring the 2 down, subtract 1. Copy the inside. And
Cosine, or negative sign.
derive the inside.
Oh, I guess.
And then the derivative of the denominator.
Negative cosine x.
And for the joke.
Yes.
Do I need 0 over something?
Yeah.
Cosine of pi over 2 is 0, right?
Right, yeah, that's not max to 0. 0 minus 1.
That.
That's not.
Yeah, that doesn't work.
Retry.
Retry.
Second derivative.
Different problem, move on. Read the limits of
Negative
functions.
2 sine x.
Yeah, I think it's just.
Limit, yeah, I think Kendra's got a good punishment.
Okay, so we do get an indeterminate form here, right?
Okay.
Are you tempted to use L'Hopital's rule again?
No.
You're tempted to, but do you need to?
No.
No.
Simplify?
We're going to algebra this.
What?
But I thought we did local.
Cosine and cosine. Right?
Oh.
So we get negative 2 sine x over
Oh, negative one.
negative 1. Now it'll give us an answer, right?
Plus negative 2 over x plus 2.
2. Okay, yeah. So sometimes you have to do another step. There are sometimes you have to do L'Hopital's rule twice. You just get your result. What can I do next? Okay, that's your mindset in this class. All right. So that, if I wanted to label, would be algebra.
Yeah.
What about?
Dealing with logs.
Are you sure?
Well, we're gonna run into it, I just know.
You are gonna hit one, so let's do that.
It's like, yeah, I played this with the homework.
Okay, is that a fraction? No, dang it. But still do your plug and chug. See if you get an indeterminate form. We could probably manipulate it into a fraction if we need to. So what do I get if I plug and chug?
I'm gonna assume 0.
0. And what's natural log if we're approaching 0 from the right?
Does 0 times 0?
It's not. Okay, natural log, the graph looks like this.
1.
Negative
Infinity.
infinity. So we're approaching 0 from the right. It goes to negative infinity. So that's an indeterminate form.
Really?
Really. Why are you confused?
0 is a number, not an indeterminate form. 0 times infinity is 0.
Yeah, infinity is not a number. It's a concept. So you're multiplying a concept times 0. Is that anything you can calculate? No, it's not. Okay, I need to rewrite this as a fraction.
Oh.
Any ideas?
Put it all in one.
You want to separate those so you don't have to do a product
Isn't the
rule.
derivative of natural log of
I'll give you a hint.
Yeah, that's one over x over x.
What's the bottom?
Zero.
X?
Nope.
Read out. No.
Minus 1.
Thank you, Jeff. Exponent
That's
rules,
not what I was
folks.
doing. I was not doing the exponent part right. That's not right.
Okay.
I just forgot.
Oh.
Right, same thing, yeah?
Oh, I can't.
You've manipulated it with an exponent.
I don't know how you do that. Because
Yeah, that like just blew my mind.
This is x to the first, right? If I, have a if I drop it underneath in a fraction, the exponent becomes negative.
Okay.
It's kind of like this, remember this rule?
Yeah,
That's that rule,
just like opposite.
but it's, yeah, it's the reciprocal of it. Okay. We've already determined that gives us an indeterminate form. So what's the derivative of natural log x? No, that's the inverse.
1 over natural log x.
1 over x is the derivative. It's just, again, that's one of those things you memorize for just such an occasion. Derivative of natural log x is 1 over x. And what's the derivative of x to the negative 1? Negative 1x to the negative second.
Oh, we just derived it, just copied it.
So again, bring the exponent down, subtract 1. Right? However. Okay, we can algebra this to make it a little bit nicer.
Negative x and the second over x.
It's 1 over x and then negative 1 over x squared, right?
Fraction.
So negative 1 over x.
So copy dot flip we get.
And then x cubed over x, or x squared, correct?
Yeah, x squared over x is just
X.
negative x. And it's 0, because 0 isn't a positive or a
X
negative.
squared over x is
Yes.
Huh? Wait, what? Yeah, x squared over x.
Oh, yeah.
I'm lost.
1 over x, copy,
Okay,
dot, and then flip, negative x squared over 1.
gotcha. Okay, see you now. We're done.
You've seen me the entire time. You just see the result.
Wait, is it negative? No, it's not.
Why is it negative?
Yeah.
Because that right there is
Wait, so it's 1 over x
times negative x squared over 1. All right, one more, and we're good to go. Solve that on your own.
Wow, that was pretty. I left that at
Who got the answer? Jeff.
I did without even doing anything, because don't you just do, the derivative of the top end line?
Well, if we're trying to find indeterminate.
Remember your number one step.
It's 0 over 1 or 0 over 3.
Plug 1 in, you get 2 and 3. There's your answer.
I didn't check.
You have to check. Okay, I pulled a fast one on you there. If it's a number, just leave it alone, man.
I was looking at it, I was just like.
Plug and chug first. If you get an answer, you're done.
What do you do when you get numerator that's non-denominator that exists?
Then it's 0,
So
0.
what's-
I guessed when I said negative 1, I got it right.
When you get denominator that's
So,
Then it's undefined.
there you go. Don't use L'Hopital's rule unless you get an indeterminate form. Okay?
undefined.
Yeah,
Questions?
because only 0 is indeterminate.
The again, you're practicing a lot of derivatives here. So if you get stuck on these derivatives, get some help. We need to move past having difficulties with calculating derivatives. Right?